Hello, I'm Reena and I'm going to talk about the time series forecasting using LSTM model. LSTM is a long stands for long short term memory. It is a type of recurrent neural network. The recurrent neural network uses sequential data or time series data to predict the next value in sequence or classify it. LSTM is helpful because it retains information for a longer period of time. So for performing LSTM model, I use the dataset from the previous assignment. The datasets are uh, taken from the Edward Aquifer, the J17 well data, Common Spring data, San Marcos data. The data after doing Kalman filtering is used to perform the LSTM model. I have attached the GitHub link to um, GitHub link of the time series analysis of the previous class. Then first the required libraries to perform the LSTM model is um, loaded. I use TensorFlow to perform the LSTM model. Then we read the data set that is of J7. This is the example of J17. To visualize the um, uh, data set versus date, I have plotted the water level elevation versus date plot. And then for performing LSTM, I have chosen one column from the data set and um, converted into a numpy array. Then the dataset is normalized using min max scalar. The min max scalar transfers each feature to given range, that is 0 to 1 in this case. This is done because it helps to avoid the large difference in magnitude of the data. It is also helpful in improving the accuracy of the model. Then the normalized data is splitted into training and testing data. I have given 70% of the data to training set and the 30% of the data to testing set. So looking at the dimensions of our data, it can be seen that around 23,000 of the data is given to training set and around 10,000 of the data is given to the testing set. Then we train the model. To train the model, the time step of 10 is taken. The past time step of data points is used as input and the next data is taken as output. The past 10 time steps is helps to predict the next value. Then we build our LSTM model. For building our LSTM model, I have used two layers of LSTM and two layers of dense layer. The LSTM layer of 50 neurons is used to return the sequences, and the LSTM of 64 neurons is used to return a single output. Then the dense layer of 16 and 1 neuron respectively is used to give the output. Then the model is compiled using Adam optimizer, and mean square error is used as loss and mean absolute error is used as the matrix. Then using the model dot summary, we can overview our architecture of the model. The summary gives the information on the type of layer, output, shape and number of parameters of our model. Then we fit the model. Before fitting the model, I've used the early stopping callback. The early stopping callback is used to stop the training once the model performance stops improving. The epoch value is given 30. It means that the dataset will pass through the model 30 times. The batch size is given 64. That means the 64 sets of data, 64 data are processed in each batch. The mm, plot here shows a plot of loss versus epochs. By visualizing the plot, we can see that the loss is decreasing as the epoch increases, which means our model is performing good. Then we predict our model using the testing data set. The model.predict is used to look at the to predict the model using the test data set. And then the uh, predictions is scaled to their original scale using scalar inverse transform. It what is does is converts our scaled prediction to original scale. And then I have created a code to visualize the training, testing, and prediction dataset in the same plot. Here we can see the blue portion is our training dataset, the green is the prediction, and behind it is a testing dataset, which is not visualized clearly now. Um, our prediction is overlapping the testing, which means our model is performing good. Then to clearly visualize the test and prediction data set, I here we can see the plot of only the testing and prediction data set. To clearly visualize it, we can look at the data of a test and prediction data set. Here you can see there is not much difference between the testing and prediction dataset, which means our model is performing good. This is the um, plot for J17 well, and I've performed the same process for Komal Spring. For Komal Spring also, while visualizing the test and prediction plot, we can see that the prediction is overlapping the test data set. Looking at the values, some of the values have a lot of difference, but uh, the model can be need some changes so that there will not be so that the changes are reduced. The same process is done like the same code was run for the San Marcos dataset. Here we can see that the model is performing good for the San Marcos dataset since there is not much a difference between the testing and prediction dataset. So to summarize the time series forecasting, we need to first normalize our data set, then split it into training and testing data set, then train the model using the sorting time step we want to use, and then build the model using the mm, mm, number of neurons we want to use to in the LSTM and Danes layer. Then the model is fitted according to the number of epochs we want to give and the batch size we want. Then the model is predicted on the testing dataset. Then it is visualized by looking at the plots and comparing the testing and prediction dataset. Thank you.